Welcome to the Sample Handling and Shipping module. This module presents the basics of tracking, packing, and transferring environmental samples from the field to the laboratory. The first subtopic explains why a chain of custody is needed and the procedures that should be followed. The second topic shows how to pack samples in such a way as to assure safe shipping and minimum breakage. Topic 6.3 lists the carriers that can be used to ship samples and lists some restrictions on shipping certain materials that can be enforced. Click on a topic to start, or click the Next button to see them in order. Click on a topic to start, or click the Next button to see them in order. On your screen you see a blank chain of custody, or COC form, used by field crews for swamp sampling efforts. This is one of several such forms. Each variant is used for a specific laboratory that analyzes samples for swamp. Other laboratories provide their own COC form to the field crews that collect samples for them. The next few screens provide examples, with focus on the type of information that needs to be captured on any COC form that you use. Every shipment must be associated with a completed COC form that lists all samples shipped and, in some cases, the analyses to be performed on these samples. Make sure you include a COC form for every laboratory you ship to, each time you send a shipment. Include region and trip information, as well as any special instructions to the laboratory. Swamp sampling crews are instructed to include the original COC sheet, not the copy, with the shipment. They insert it in a Ziploc bag into the cooler. They keep one copy and send one to the sampling coordinator. However, in many situations, you will be instructed to have the COC form accompany the sealed cooler and have it accessible to custodian signatures along the way. It is your responsibility to find out how you need to handle this. You will get a closer look at the parts of the COC form in the following screens. There are many variations on the structure of COC forms, but all of them should provide the essential sample identifiers. Some programs use the station ID, date, and time to create a sample ID in the database, while others create a unique sample ID in the field, have the operators write it on the labels, and use it to track each sample through the handling, analysis, and data reporting process. The sample ID is often derived from the station ID. Check out your project's naming conventions and the way your data will be managed to figure out how to fill the station or sample information. You may collect more than one sample container at a time. If so, it will be much easier if all the containers from one set have the same collection time. In fact, this is essential for the swamp data management system. Use military time if possible to avoid confusion. Adding the total number of containers that belong to that sample and are shipped under this custody form is very helpful too. The second half of the COC form can include more information about which analysis is being requested for each sample. If the samples have been preserved in the field or in your staging area before packing, describe which preservatives were used. You might also need to use the comments field to warn the laboratory personnel about potentially hazardous samples. Some COC forms contain information on the types of containers dispatched. For example, 500 milliliter plastic bottle for trace metal analyses. Another variation will have a generic list of analyses across the page, and the dispatcher will make check marks or X's in the appropriate boxes. The Swamp Toolbox contains several COC options. Please note that the specific way swamp field crews are instructed to fill out their COC forms to accommodate the swamp database is described in the PowerPoint presentation on your CD. Whichever form you choose, remember that the key word is communication. Beyond the information that needs to accompany the samples regarding collection and requested analyses, the chain of custody form has a very important legal function that should not be overlooked. It is a document that assigns responsibility to all parties that have handled the samples and tracks the progress of sample transfer over time. Parts of this documentation may be done via the shipping label. Find out how. In many cases, the coolers themselves are wrapped by field personnel in a seal of custody tape. An intact seal proves that samples have not been tampered with. and only the receiving lab may break it. COC forms usually have placeholders for 2 or 3 transfers, and each transfer is documented in one row which includes both the relinquishing party and the receiving party. Dates and times entered into one row are usually the same, unless the coolers are left by the relinquishing party in a staging area and are picked up by the receiving party later. The field operator who collected the samples will use the first row, whether they are transferring the samples to other crews for packing, or to the couriers, or to the carriers. In most cases, the COC travels with the samples outside of the cooler, so it will be accessible for custody signatures along the way. However, in some cases, as you will see in the next section, it is okay to simply pack it with the samples inside the cooler. Due to increased shipping restrictions, samples being sent via a freight courier require additional packing. All samples that are being shipped to the various laboratories must follow the sample packing rules in order to assure the quality of the sample. The next few screens will show you the basic processes. The same content, including sample packing and cooler labeling, is also demonstrated in a video. Click on the button to view the packing video.
When preparing a cooler for shipping, there are many details you want to follow to make sure that the samples are safe and not broken and get to the laboratory on time. First of all, we fill out a chain of custody form to make sure that to log all of our samples that we collected, the date that they were collected, the time that they were collected. Usually we like to record the salinity of each sample just so the laboratory can know. And we put the COC in a plastic bag, tape it to the roof so it does not interfere with any of the ice or any of the water in the cooler, so the laboratory can read it properly. We also want to line the bottom of the cooler with bubble wrap to prevent, if the cooler was dropped or somehow mishandled during shipping, to prevent any bottle breakage in the cooler. Next, we would want to put a large plastic trash bag into the cooler to seal all of the ice and all the water samples in the cooler to make sure that if something does happen to the ice or the bottles, that water will not leak out of the cooler. We then bubble wrap all of our glass bottles securely, making sure that the bubble wrap is all the way to the top of where the glass is, and then we start placing them in the cooler. Depending on the number of bottles that you have in your cooler, you want to make sure that the bottles all fit pretty tightly and snug with bubble wrap in between each bottle. We do have some loose spaces, so I will take some loose bubble wrap and stuff those down in the empty spaces. We then double bag our ice, making sure that no water or ice is going to leak out of this bag. As you can see, I have one end of the bag on the top here, and then I also have the other inner bag with the top inside the outer bag. We also want to make sure that all of the sample bottles want to be brought down to 4 degrees Celsius before putting them in the cooler. This ice sitting on top of these bottles is not enough to bring these bottles down to 4 degrees C. Therefore, it's always good to put your sample bottles in a separate cooler with ice before shipping. We then place double bag ice on top of the samples, making sure if there was any extra space around that we would want to wrap that with bubble wrap. Samples are ready to be shipped. We can then close the cooler, making sure that when we close the cooler it's not too compact to where we're smashing any bottles or anything inside. This shuts pretty good. We then want to securely tape the cooler closed, also making sure that the spigot on the cooler is also taped closed in case during shipping it could come open and leak water. If coolers do leak water during shipping, the shipping companies usually stop shipping them, and they will hold them in some shipping facility, and the samples will not arrive to the desired laboratory. We then want to tape the cooler closed on two sides, and we want to wrap the tape, which is clear tape, not duct tape, at least a couple times around the cooler. Again on the other side. We also want to tape around the seal of the cooler just to ensure that no water is going to leak out. The cooler is then taped, closed securely, make sure all the tape is fastened. We then want to attach a shipping label, and the ideal way to do this is if you have a handle on your cooler. There are usually fasteners that you can use to fasten to the cooler. A lot of times if you stick the shipping label on top of the cooler, the coolers get stacked and the shipping label is going to get ripped off in the shipping process. Therefore, the cooler is unknown of where to go. And then stick the shipping label onto the label holder, making sure it's secured, making sure your addresses are all filled out, everything's filled out as should be on the shipping label, and you're ready for shipping.
You learn to chill the samples immediately in Module 4, and it is assumed that they are adequately chilled when you start this packing process. The next steps have to be done rapidly to avoid heating of the samples. All glass containers must be wrapped in a non-soluble bubble wrap in order to prevent any breakage during shipping. Cardboard or newspaper will not work since the packing material will get wet and lose its integrity in the shipping process. Glass sample bottles with bubble wrap should be packed inside the cooler so that they do not slide around during shipping. First, put a large plastic bag inside the cooler and hold it open. Next, put a layer or two of bubble wrap on the bottom of the cooler. Take the samples out of the refrigerator or other cooler and wrap each one in bubble wrap. Then, pack the glass bottles upright in the cooler without spaces between them. Fill the crevices with bubble wrap too. Shake the cooler to make sure that the samples cannot move sideways at all. Last, the COC is placed in a sealed plastic bag and taped to the inside of the cooler lid to prevent water from leaking onto the COC. If you are the relinquishing party, you need to sign and date it before you put it in the bag. It is your responsibility to find out whether or not the COC is essential for tracking the actual chain of sample custody, and it is always a good idea to have a copy signed by the person who took the sample from you. In that case, you may need to put a copy with sample inventory and requested analyses in the cooler, but keep the original COC outside the cooler. Next, cover all of the bottles with one or more layer of bubble wrap. Ice must be double bagged to prevent any melted water from interfering with the samples. Another option, favored by many, is to use blue ice frozen packs. In any case, the samples must be at most 4 degrees Celsius before shipping in order to maintain the sample quality. Then add more packing materials to make sure the bottles don't move around. The large plastic bag, which was placed around the outside of the samples to prevent any water from leaking outside the cooler, can now be sealed by simply removing excess air, twisting the bag closed, and taping the tail down. All coolers must be wrapped in tape multiple times to ensure that the cooler will not open during shipping. If you ship using FedEx, use transparent tape, not duct tape. Even if you are very careful in sealing the ice chest, leaks can and do occur. Prior to shipping, the drain plug of these ice chests has to be taped shut. This can be done with duct tape. Leaking coolers can cause samples to be returned or to arrive at the lab after the holding time.